Alright, silly people, here's the situation. We have these three basis vectors, e1, e2, and e3, which Griffiths gave us, and he's going to run us through a process of orthonormalizing them. And so, to start off with, he wants us to actually just normalize the first one, so we need to find that e1 prime vector is just the vector itself divided by its norm, so the norm just being the square root of the inner product, right? So let's write that out in full. It's going to be 1 plus I hat plus j plus I k hat all over, this is going to be the square root of 1 minus I times 1 plus I plus 1 minus I squared for the square. And then we can expand the terms on the bottom a little bit more, because we can actually do that multiplication between 1 minus I and 1 plus I. So it's going to be 1 minus I plus I minus I squared. And then we also have the 1 from before, and also minus I squared is just equal to 1. So the i's by themselves will cancel out, and then minus I squared is, again, it's 1. So the whole bottom part of this just looks like the square root of 4, actually. Square root of 4. But the square root of 4 is just 2, so let's write 2 down there instead. And that's a perfectly sensible way of writing it. The next step is to take the second basis vector, e2, and subtract off the projection of e1 onto e2. Or I guess it's the projection of e2 onto e1, but yeah, we subtract that from e2. So we have that e2 was I hat plus 3j hat plus k hat, and then the this square here is going to be it's going to be pretty big. It's going to be I times 1 minus I. Yep. And that's over 2. We've also got plus 3 over 2 plus, or actually this is going to be minus I over 2. And then in here we just have the normalized vector e1. So just this here. Right. Let's collect all of the denominators into a minus 1/4 out front. But then this is going to be I minus I squared plus 3 minus I in the square, and then we still have this stuff in here. So this I is going to cancel out this I. Minus I squared is just 1. So we actually have in those parentheses a factor of 4. So it's going to be minus 1/4 times 4 times the vector e1. And I've been miswriting that. There's supposed to be some i's here. Plus I k hat. And then those 4's cancel out. So we just have to subtract now. Carrying out that subtraction, we've got I minus 1 plus I. So it's just 1. So So this is just I hat. We've got 3 minus 1j, so just 2j. And then we've got 1 plus I on the k, or actually 1 minus I on the k. 1 minus I k hat. It's minus I hat because we're subtracting 1 minus I. But yeah, that looks good. Then we have to normalize this to find E2 prime. So that's going to be what we just found, divided by the square root of the inner product of this with itself. So we've got just 1 plus 4 plus 1 minus I times 1 plus I. And then we already know that this combination of 1 minus I and 1 plus I gives you 2 from before. So I hat plus 2j hat, supposed to be k hat here, plus 1 minus I k hat. And this is going to be 1 plus 4 plus 2, so it's just 7. Okay. Root 7 on the bottom is good. The next step is to take the E3 basis vector and subtract off the projection of E3 onto E1, which is going to look like this, and also subtract off the projection of E3 onto E2, which is going to look like this. Okay, so E3 was just 28j hat. Yeah, the projection of E1 onto E3 is just 28 divided by 2, which is 14. So this is 14. And then we can write out what E1 was again, because it was 1/2 of 1 plus I hat plus j hat plus I k hat. And then the inner product of E2 with E3, you just multiply the j components. The j component before was 2 over root 7. So we've got 28 times 2, which is 56, divided by root 7. And then we've also got the E2 vector, which was 1 over root 7 times minus I hat plus 2j hat plus 1 minus I k hat. Okay. So simplifying this, the 14 over 2 is just minus 7. So we have this times I hat minus 7j hat minus 7I k hat. 56 over 7 is 8. So we actually have minus or plus 8 I hat minus 16j hat minus 8 times 1 minus I times k hat. Okay. Let's do some subtraction now. 28 minus 7 minus 16. So 28 minus 7 is 21. Minus 16 makes 5. So we've got 5j hat. We've got, on all of the I hat stuff, it's 8 minus 7 times 1 plus I. So we get 1 minus 7i. So 1 minus 7i hat. And then for the k hat stuff, we've got minus 7i k hat minus 8 times 1 minus I. So we've got 8i minus 7i. So I minus 8 k hat. And that looks about right to me. Okay, cool. Um, Finally, we have to normalize this so to find E3 prime. So we take E3 prime, or we take E3, which is now looking like 1 minus 7i I hat plus 5j hat plus I minus 8k hat, and we divide it by the square root of the inner product, which looks like 1 minus 7i times 1 plus 7i plus 25 plus I minus 8 times I plus 8. Or it's not the 8s that switch the signs, it's the i's. So it's I minus 8 times 8 minus I. No, minus I minus 8. Yikes. But yeah, looks kind of like that. So just writing out the top side of the fraction again, we can start simplifying the stuff in the radical, because this is going to look like 1 minus 49i squared, whoops, I squared plus 25 plus 64 minus another I squared. But then we know that we know that minus I squared is just 1. So in the radical, we're going to have 2 plus 49 plus 25 plus 64. What in the world is that? 64, 25, 49, 2. So 18, 20, 8 plus so 14. It's the square root of 140. I feel like there's a way to simplify that probably. Yeah, 140 is divisible by 4, so we can pull a factor of 2 out of the radical then. And then 140 divided by 4 was 35. So we get that sort of thing. And I think that looks good to me.